Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0112, refers to an issue with the intake air temperature IAT sensor circuit, indicating that it has low voltage. This sensor is crucial as it helps to measure the temperature of the air entering the engine, which is integral for the engine control module, ECM, to determine the right fuel-to-air mixture. The IAT sensor is located near the mass airflow MAF sensor, making it susceptible to issues if connections are poor or if there's wire damage. When the voltage reading from the IAT sensor is around 0.08 volts or less, or if the temperature reading is greater than about 356 degrees Fahrenheit, 180 degrees Celsius, it signifies a malfunction. Understanding this error helps in pinpointing where the failure might have occurred in the vehicle's systems, specifically in the IAT circuitry or connections. The intake air temperature IAT sensor is designed to monitor the temperature of the incoming air into the engine. Its role is crucial as it feeds data to the engine control unit ECU, influencing fuel mixtures and ignition timing for optimal engine performance. This sensor is commonly located in conjunction with the mass airflow MAF sensor, which is found in the air intake path leading into the engine. A malfunction in this sensor, as indicated by DTC P0112, can result in poor fuel economy, increased emissions, and can lead to engine performance issues like stalling or rough idling. Additionally, the location of the sensor makes it susceptible to environmental factors, which may lead to intermittent readings. Proper diagnostics ensure that the right components are addressed effectively to restore vehicle functionality. Several factors can lead to the setting of DTC P0112. Firstly, poor electrical connections at the MAF or IAT sensor can interrupt the signal that is being sent to the engine control module, ECM, resulting in low voltage readings. Secondly, a malfunctioning IAT sensor itself may be the root cause, which could arise due to age, wear, or external damage. Lastly, a short in the TA wire connecting the sensor to the PCM could also cause this error. Each of these causes points to issues in the electrical system that need to be addressed for the vehicle to run properly. Proper diagnostics are critical to isolate which of these potential failures is actually impacting the vehicle's performance. When DTC P0112 is active, several symptoms might manifest, signaling a larger mechanical or electrical issue. Drivers may observe unexpected engine performance, including stalling or difficulty accelerating. Poor fuel efficiency can also be a significant indicator as the vehicle struggles to maintain an optimal air-fuel mixture. Additionally, increased emissions levels can be noted, which may trigger the check engine light as a warning. Each symptom is tied back to the failure of the IAT sensor to provide accurate data, thereby affecting engine performance and compliance with emission standards. Monitoring these symptoms is essential, as they not only impact the vehicle's drivability, but also can result in penalties regarding environmental compliance. The first step in troubleshooting DTC P0112 involves verification of the problem. Start by turning the ignition switch to the on position, ensuring that the electrical systems are active without starting the engine. Using the Honda Diagnostic System, HDS, check the readings from the IAT sensor. A key indication that a fault exists is if the temperature reading exceeds approximately 356 degrees Fahrenheit, 180 degrees Celsius, or if the voltage is 0.08 volts or lower. If either of these conditions is confirmed, this confirms that the failure has duplicated, leading to the next troubleshooting step. Otherwise, if the readings return to normal, it indicates an intermittent failure, suggesting that connections might be loose or faulty, warranting a check of the MAF sensor/IAT sensor and the PCM connections. Step 2 requires determining the probable failure area, focusing primarily on the IAT sensor. Begin by turning the ignition to the off position or locking it. Following this, you'll need to disconnect the 5P connector from the MAF IAT sensor. This is a critical step to isolate the sensor from the circuit. After disconnection, turn the ignition back to the on position without starting the engine. Once again, utilize the HDS to check the IAT sensor's readings. If the readings still indicate that the temperature is at or above about 356 degrees Fahrenheit, or 0.08 volts or less, this confirms a definitive failure of the sensor. If normal readings return, it suggests that the MAF IAT sensor should be replaced. The third troubleshooting step involves checking for a short in the TA wire, which is a critical part of the circuitry connecting the IAT and MAF sensors to the engine control module ECM. Start by turning the ignition to the off position. Then jump the SCS line via the HDS to facilitate testing. Disconnect the PCM connector B51P to ensure that there is no interference from the module while testing the circuit. With these connectors disconnected, perform a continuity check between the designated test points, the MAF sensor IAT 5P connector number 4, red-yellow, and a body ground. If continuity is present, it indicates that there is a short in the TA wire between the PCM and the sensor. Addressing this fault is essential for restoring proper function. Conversely, if continuity is not found, this confirms the wire is intact, leading to potential PCM updates or replacement. Upon completing the necessary repairs, the next crucial step is verifying that the fixes implemented have effectively resolved the issue signified by DTC P0112. This entails rechecking the readings from the IAT sensor using the HDS. After confirming that the sensor is providing accurate temperature readings without exceeding 356 degrees Fahrenheit or indicating low voltage, it's also vital to perform a systems check to ensure that there are no remaining fault codes present. If the DTC has cleared, it verifies the solution's effectiveness, indicating that the necessary adjustments or replacements were successful. This step not only confirms the repair, but assures that the engine can now operate as designed without further interruptions. To prevent reoccurrences of DTC P0112, implementing a routine maintenance schedule focusing on the IAT and MAF sensors is essential. Regular inspections of these sensors can identify potential wear and tear before they lead to failures. Checking electrical connections periodically, including terminals for corrosion or looseness, can help maintain reliable functionality. Additionally, ensuring that the wiring harness is free of any damages will bolster the integrity of the connections. Properly securing and protecting these components against environmental factors can extend their lifespan dramatically. Lastly, encouraging the use of high-quality replacement parts when repairs are necessary will ensure that the sensor operates effectively and efficiently over time. Addressing DTC P0112 necessitates a comprehensive understanding of the IAT sensor's function and its integral role in engine performance. By recognizing the importance of reliable electrical connections, technicians can effectively tackle issues related to low voltage readings. The systematic troubleshooting steps outlined allow for a methodical approach to diagnosing the root cause of the problem, whether it lies within the sensor itself, its wiring, or the engine control module. Following the steps ensures minimal downtime and enhances the likelihood of successful repairs. Lastly, emphasizing preventive maintenance will keep the sensors functioning correctly, preventing additional complications down the road. Understanding and addressing DTC P0112 not only enhances vehicle performance, but also assists in maintaining emission compliance. Please like and subscribe to the channel. See you next time.